All right, let's dive right in. We're going to talk about one of the biggest challenges brewing right under our noses, the absolutely massive energy problem that AI is creating. And we're going to explore a powerful and, yeah, pretty controversial technology that might just be the only thing that can solve it. Okay, get ready for this. Here's a single number that tells you almost everything you need to know. By 2030, just a few years from now, data centers, the engines running all this AI, could be eating up 9% of all the electricity generated in the entire United States. Seriously, pause and think about that. Nearly a tenth of the nation's power just for computing? This is not a small leak, it's a fire hose of new demand.
And this is not just a US problem, not by a long shot. Globally, if we keep powering this AI explosion the way we do now, we're on track to pump an extra 1.7 gigatons of greenhouse gases into the atmosphere in just 5 years. To give you some perspective, that's a colossal amount. It's an enormous environmental bill that's coming due fast.
So yeah, this is what we're calling the AI energy dilemma. We have this incredible technology that's supposed to help us solve the world's biggest problems, but it's creating a monster of a problem for our power grids and our climate goals. So the big question becomes, how in the world do you power this future without, breaking the planet?
And look, this isn't some hypothetical 30 years from now issue. It is happening right now, and it is speeding up like crazy. Data center energy consumption is already through the roof, and the projections show it could triple again by 2030. So every time you use a chatbot or an image generator, you're plugging into this just exponentially growing hunger for power.
So, with this crazy need for clean, reliable power, and lots of it, a new contender is stepping into the ring. And it's a modern spin on an energy source that, let's be honest, we all have strong opinions about. We're talking about a completely new way of thinking about nuclear power. Now, let's be super clear on what these things are. These are not the giant, sprawling nuclear plants of the past. Small Modular Reactors, or SMRs, are a total game changer. The idea is to stop building them like cathedrals, these huge one-off projects that take decades. Instead, you build them more like cars, in a factory, on an assembly line, with standardized parts, and then you just ship them where they need to go.
And the differences here go way beyond just size. Yeah, they're smaller, and they're built in a factory, which makes them faster and more consistent. But the real revolution here is safety. Traditional plants use complex active systems, pumps, valves, backup generators. SMRs are designed with passive safety. They basically use the laws of physics, like gravity and natural circulation, to shut themselves down safely. No power required, no human intervention. It's safety by design.
Okay, this is where the story gets really, really interesting, because this isn't just about SMRs giving power to AI. What's so wild is the potential for a real partnership here, a symbiotic relationship, where each of these powerful technologies actually makes the other one better, safer, and more efficient. You can see this perfect feedback loop right here. Step 1, SMRs pump out the clean, 24/7 baseload power that these hungry AI data centers have to have. But then, the AI turns around and returns the favor. It can run millions of simulations to help engineers design better, safer reactors. It can monitor a plant's operations in real time and predict when a part might fail before it actually does. It's a cycle that could lead to a generation of nuclear power that's just smarter and safer than anything we've ever imagined. And one of the coolest bits of tech making this happen is something called a digital twin. Just imagine this. You create a perfect, one-to-one virtual copy of a real operating nuclear reactor inside a supercomputer. With that digital twin, AI can test absolutely anything. What happens in an earthquake? What happens if this part wears out over 30 years? You can simulate it all in hours, with zero real-world risk. It's an incredible tool for safety and performance. But okay, before we get too carried away with this amazing sci-fi vision, we need a reality check. This powerful alliance is not a done deal, not even close. The road from a cool concept to an actual working power plant is full of some very serious real-world roadblocks. And these hurdles are no joke. On the technical side, these are brand new designs. We just don't have decades of data on how they run. From a regulatory standpoint, every country has its own rules, which kind of messes up the whole build them in a factory and ship them anywhere idea. And then you get to the really big ones, money and people. We're talking about huge upfront costs. And maybe most importantly, you have to earn public trust. That's absolutely crucial. So when you put all the pieces together, we're left with this huge, critical equation for our future. On one side, you have this almost bottomless demand for energy from AI. On the other,
You have this powerful, promising, but still unproven solution. And how we solve that equation is pretty much going to define the next chapter for our planet. So let's just boil it all down. The need? It's undeniable. AI's growth demands a totally new energy playbook. The potential? It's definitely there. SMRs could be the low-carbon powerhouse we're looking for. The synergy? It's fascinating. The idea of AI and nuclear making each other better is compelling. But the challenge? Well, the challenge is very, very real. Getting this done means navigating a minefield of technical, financial, and social issues. And that leaves us with a pretty wild final thought, doesn't it? We're seriously talking about an alliance between two of the most powerful and, frankly, most feared technologies humanity has ever created. One reshapes what it means to be intelligent, and the other reshapes the atom itself. So the ultimate question isn't just can they work together, it's should we trust them to? That is the equation we're all going to have to solve, together.